The dog's horizontal displacement relative to its kennel is given by this sine function. In essence, it's really easy to calculate the dog, whether the dog is on the left-hand side or the right-hand side, just by substituting t is equal to 3 and t is equal to 7 into this equation. Using the graphics calculator, we just get 7.9799 meters. Now, you don't need all these decimals, but I did it for a reason. And in this particular question, we don't really even need to give that number. All we need to say is whether it's to the left or to the right. Well, we know that positive means that that the dog is to the right of the kennel. And when we do the calculations for the 7 seconds, we find that we get a negative number of 2.806 meters. Now that means that the dog is now to the left. And that's all we need. But as a student of mathematics, you should understand what a sine function is. It's a cyclical function of the form a sine bx, where a is the amplitude and b determines the period of the function. If you look at this sine function, you note that the period over here is defined as 1 cycle, and it would end over here. So this particular sine diagram has actually 2 cycles, so I'll just draw this over here. And 1 cycle is defined from the beginning here to 1 cycle is usually 360 degrees, or we use 2 pi. In this case, our Desmos will show you that we've got a scale of from 0 to 6 something. That's because 2 pi is equal to 6.28. So pi is equal to 3.14, as we know. And this scale, it has that numerical value of pi. Okay, a sine function which has a period of 2 pi is usually seen as sine x, where the b is equal to 1. On the other hand, a sine function which can fit 2 cycles in 2 pi will be now called 2x, sine 2x. And this follows that a sine function which can only fit half of its sine function into 2 pi will now be half x. And this is the case in our problem, because our problem says, and our problem defines the sine function as a 8 times sine half t. Now, may I remind you that 8 means that the amplitude is 8. All these sine functions that I had drawn so far were just up to 1. So we will need to draw a sine function with an amplitude of 8. And the displacement at 3 seconds was 7.9799. Since the maximum is 8 meters, you can see that our dog is nearly at the maximum distance from the kennel. After 7 seconds, he is 2.8 meters to the left of the kennel. Remembering that this point here indicates 2 pi, or you could say that is also 6.28 seconds. It is important that you see this in terms of these graphs, because it gives you a clue to what the function is doing. Anything above will give you a displacement to the right, and anything below, as in here, is going to give you a displacement to the left. Also, knowing what the period of that sine function is going to help you as well. That wasn't part of the question, but I still wanted you to see what is actually happening. Now, by differentiation, we're going to be able to find out what the velocity function is. And we keep the 8, but we change the sign into a cos half t, and then we multiply this by a half. All of that ends up looking for cos half t. So our function is going to be also have a period of a half, but it is going to be a cos function, and it is not in amplitude, it'll be only 4 meters high. And you could similarly draw a cos function, but this time it will only reach 4, and these here values will be, this will be our 2 pi, which will be 6.128, and this will be 3.14. And it's not hard to see that after 4 seconds would be somewhere in this vicinity, you are going to have a negative value, which means that the dog will be moving to the left. And at 10 seconds, which probably will be already on this side of this value, because this is going to be about 9 something. So at 10 seconds, we will see that the dog will be moving towards the right. And we can check that by writing down, substituting 4 here, and also the equation is 4 cos, and that will be 4 over 2, and using the graphics calculator, we'll get a value of minus 1.66, which means that the dog is moving to the left. And also, if we do it at 10 seconds, we have 4 cos 10 over 2. And once again, using the calculator, we'll get something like that, 1.1, which means that the dog is now moving to the right. And we were able to find all that out just by drawing our cos function. And lastly, we want to show that the dog's speed is maximized when it's moving past its kennel. Okay, just from this velocity graph, I can already tell when that speed is maximized. Its speed is maximized when its acceleration is 0. That means either here or either at the top over here, which means when it is 0, when it is 2 pi, and when it is 4 pi here, and obviously so on and so on. But let's prove this. So when velocity, let's differentiate the velocity function now to find out the acceleration of this, because we want to make it to 0. So acceleration then therefore will be minus 4 sine, because cos becomes minus sine, and we might have to multiply it by a half because it's chain rule. This will then become minus 2 sine half t. Okay, but we have to make it equal to 0. So minus 2 sine half t, which really can be just put down as sine t over 2. Okay, so when is sine equal to 0? If we just have a look at our circle here, unit circle, and over here we've got 1, 0, 0, 1. Over here we've got -1, 0, and coordinates of that one is 0, -1. Okay, so sine is only 0 here and here, which says that it is 0 when it is pi, 2 pi, which means that t over 2 must be either pi or 2 pi or 3 pi, which really means that t must be 2 pi or 4 pi or 6 pi, which really means that t must be 2k pi, where k is any integer. At those times, the dog speeds is maximized when it is moving past its kennel. But when is it moving? But we ask ourselves the question, where is the dog at these times? What is his displacement? So let's have a look at the displacement at 2k pi is 8 sine 2k pi over 2. So we have 8 sine k pi. And whenever sine is any value of pi, 2 pi, 3 pi, we know that it will be 0. So what does a displacement of 0 meters mean actually? Well, if we've got our dogs here and its kennel is up here, the displacement is 0 at the kennel, and remember that the dog walks up to the left 8 meters and he also moves up to the right 8 meters, because that's the way he was cycling about, going left and right. And when his displacement is 0, it means that it has walked past its kennel.